Hello guys. In this lecture, we will understand the resonant circuit for generation of high voltage AC at power frequency. In this method, we will make use of electric phenomena which is resonance to generate high voltage AC at power frequency. Before understanding this method, let's get a simple revision and background about resonance. Resonance in an electric circuit occurs at particular frequency when the imaginary parts of the circuit elements cancel each others. So what is the meaning of that? If we have this circuit, RLC circuit, with a supply, has voltage F and has a frequency F. If by chance the reactance of the capacitor equals the reactance of the inductor, which means that XC equals XL, which means also the effect of the capacitor cancels the effect of the inductor. They cancel each others. At this moment, resonance occurs. So the main condition of resonance is that XL equals XC, the reactance of the inductor equals the reactance of the capacitor. So omega L equals 1 over omega C, as omega L is the reactance of the inductor and 1 over omega C is the value of the reactance of the capacitor. So from this equation, we will get omega resonance, the angular frequency at which resonance occurs, equals 1 over root LC. So the F resonance, the frequency at which resonance occurs, equals 1 over 2 by root LC. So what is the meaning of that? If the supply frequency equals this value, the resonance frequency, which is 1 over 2 by root LC, this means that resonance will occur. Also, at this moment, as the effect of the capacitor cancels the effect of the inductor, they cancel each other, the supply will see only the resistance. So the equivalent impedance at this moment at resonance will equal R, which is minimum value. Also, the current flowing in the circuit I, the current that flowing in the circuit I, this current will be equal the supply voltage V over the equivalent impedance at this moment. At resonance, equivalent impedance is R, so the current will be maximum value. Also, we have VC, which is the voltage across the capacitor, will equal the current times the reactance of the capacitor XC. So this value will equal V over omega CR. So this value can be written as voltage V times 1 over omega CR. The value 1 over omega CR is called quality factor, and its value is in range between 20 and 50. So the voltage across the capacitor here at resonance may reach 20 to 50 times the supply voltage, as this value ranges between 20 or 50. So the voltage across the capacitor can reach 20 to 50 times the supply voltage. So we can make use of this phenomena to increase the voltage across the capacitor. In our high voltage lab, the capacitor represents the insulator. So the summary of this phenomena: to produce high voltage using resonant circuit, we have two methods. First method is adjusting the supply frequency to be equal the resonance frequency. This method, if we have the supply with variable frequency, we can adjust the supply frequency to equal the resonance frequency, which is 1 over 2 by root LC. But this is not our case, as we want to generate high voltage AC at power frequency. So we want the supply frequency constant and equal 50 or 60 Hertz. So we will go to the second method. To produce high voltage across the capacitor, which is insulator in our lab, we use a variable inductor to get omega L equal 1 over omega C, which is the resonance condition. Adjust the L to make omega L equals 1 over omega C at constant supply frequency, which is the power frequency, and this is our case. So this is the equivalent circuit. We have the supply frequency constant here, 50 or 60, and we have a variable inductor. This value of inductor is designed and adjust it to get omega L equal 1 over omega C. Now let's see our circuit, series resonance circuit for high voltage generation. It's also called resonant transformer. This is our circuit for producing high voltage AC at power frequency. First we have AC supply. Here we have AC supply 220 volt. Also we have a high voltage transformer to produce high voltage AC. Also we have here a choke coil, which is a variable coil or variable inductor to adjust its value to make resonance. Also we have a capacitor C, which represents our insulator in the high voltage lab. This circuit will be the right circuit as we saw. This is the supply, and this rectangle is the equivalent circuit of high voltage transformer, and this equivalent circuit finally can be represented as equivalent resistance and equivalent inductor. So finally we have a resonance circuit, and this coil is the variable coil or choke coil to be adjusted to make resonance. So this method is used to produce very high voltage AC. The inductance L is changed to satisfy the resonance condition omega L equals 1 over omega C. When resonance is achieved, the voltage across the capacitor, which is insulator in our case, is amplified, and high voltage AC is produced across the insulator. So this is a simple operation of series resonance circuit for high voltage generation. We make use of resonance phenomena to produce high voltage AC at power frequency. Advantages of series resonance circuit. First, pure sine wave output is obtained, no harmonics in this method. Less power requirements. Cascading is possible to produce very high AC voltage, and simple compact arrangement. Disadvantages of a series resonance circuit. Tuning of choke coil is difficult. This means that adjusting the coil to make a resonance occur, this adjusting of coil is difficult, and also the choke coil should be capable of withstanding the full test voltage, so this coil will have special specifications to withstand the full high test voltage. So this is a complete understanding of a resonant transformer for producing high voltage AC at power frequency.